Hi everyone, today I'm gonna show you chemiluminescent reaction with green tea. The glow in this reaction is due to singlet oxygen, but it's formed here not in a way you have seen 100 times on YouTube. Usually the glow of singlet oxygen is demonstrated in two ways, and in both cases you have to deal with toxic chlorine gas. The first way is by passing chlorine to an alkaline solution of hydrogen peroxide. This produces a quite bright glow. The second way is simpler. You need to take pool chlorine, specifically trichloroisocyanuric acid, and add hydrogen peroxide. It's a very simple experiment, but unfortunately a lot of chlorine gas is released in this reaction, which isn't pleasant at all. Today I am going to show you the Trautz-Schorigin reaction, which is another, less well-known way to demonstrate the red glow of singlet oxygen, and it doesn't require such aggressive conditions and reagents. The variation of this reaction I will show in this video even uses green tea as the main component. In the original demonstration, paragalol or gallic acid is used. It is oxidized in an alkaline environment by hydrogen peroxide in the presence of formaldehyde. Here is the reaction mechanism. Pyrogalol is first oxidized to orthoquinone, then the reaction can proceed in two ways. The first way is polymerization, and the second is dimerization, the cross-linking of two molecules with the subsequent breaking of one of the rings. Both pathways generate singlet oxygen. The only thing I am a bit unclear about is the role of formaldehyde in this process. If you know anything about it, please write in the comments. But it's not just pyrogalol that participates in this reaction. Green tea contains a significant amount of tannins, which are derivatives of pyrogalol and gallic acid. This fact allows us to use just brewed green tea in this reaction. There is even an article about it called the glow in tea cup demonstration. Here is the original procedure. Pause and read if you are interested. In the video I'll deviate from it a bit because I don't have all the reagents. It should be noted that this procedure uses paraformaldehyde, which is a polymer of formaldehyde, and it needs to be added specifically to the hot tea solution, at which point it depolymerizes to form formaldehyde. I don't have paraformaldehyde, so I'll use simpler solution of formaldehyde, that is formalin. It can be added to a cold solution. So for the demonstration of the reaction I used the following reagents. A green tea bag, hydrogen peroxide, 10 ml, 30%. The original article uses a 3% solution from pharmacy, but I don't have pharmacy grade peroxide, so I'll take 30% peroxide in a proportionally smaller amount. 20 grams of sodium carbonate, specifically sodium carbonate, not baking soda, which is sodium bicarbonate. 20 milliliters of formalin. So first we brew the tea in 200 milliliters of boiling water. Wait 3 minutes and add 20 grams of soda. Cool it down and add 20 milliliters of formalin. To 15 milliliters of this solution I add 10 milliliters of hydrogen peroxide and observe red glow of singlet oxygen. I also did this reaction in tea cup just for fun. Never do this. Mixing or storing chemicals in anything that resembles foodware is strictly prohibited. Unfortunately, the glow of one tea bag is quite weak. It will only be noticeable in complete darkness, as a fine ghostly reddish glow. It looks good on camera only because I used my Sony a7S for filming, which is extremely light sensitive. Here is a shot from another camera. This image is quite close to what I saw with my eyes. This result didn't satisfy me, so I repeated the experiment, brewing a whole 10 tea bags in the same amount of water. I added the soda to the hot solution, then cooled it and added formalin. After adding the peroxide, the glow was much brighter. It was already visible not only in complete darkness. Still, the glow is weak in my opinion. It doesn't even come close to luminol. Next time I'll try the classic reaction with gallic acid, which I just ordered. I also saw a modification of this reaction on YouTube using luminol. This combination gives a very unusual effect. The color of the luminescence changes from red to blue, which looks simply amazing. I will definitely try this variant when I get some luminol. That's all for today. Thanks for watching. Goodbye.